Hey guys, in this video we'll be going through examples of how to solve for 2D motion problems in scenarios where we throw an object horizontally. Okay, so if you guys turn to I believe this is page 4 of your packet, and we're going to start with example 1 here. Okay, so a stone is thrown horizontally at a speed of 5.0 meters per second from the top of a cliff that is 78.4 meters high. So, start off, we're going to work in this space on the side and divide all of our variables into x and y columns. Okay, so we have a speed of 5 meters per second, a stone that's thrown horizontally at that speed. So this here is our velocity in the x direction, and we're going to list that there as 5 meters per second. And then we're also given here a height of the cliff, 78.4 meters. This here is our distance in the y. Okay. After that, we list our assumptions. As always, acceleration in the x is 0 meters per second squared. In the y direction, it is 9.8 meters per second squared. Okay, what else is there? Let's make this longer. Okay. Well, we always have initial velocity in the y equaling 0 meters per second. And there's always time, which connects both dimensions, time. Okay. But we don't know that yet. So if we take a look at part A, how long does it take the stone to reach the bottom of the cliff? And here we give us a hint, only the y-axis matters here. So, looking at our equations and the information that's given here, the hint applies to this question where we look at the y-axis. We look at our information here in the y-axis and check the equations here to see where we can solve for time. And we can solve it looking at this middle equation. D is equal to VIT plus 1/2 AT squared. So let's do that. So on this space here, we're going to solve for time. Distance here in the y is 78.4 meters. This is equal to VIT, so that crosses off to 0. So we're just left with 1/2 9.8 meters per second squared t squared. And when we solve for t, you guys should get a time of 4 seconds. Okay. Since we solved that in the y and time is the only variable that crosses over, we can write that over here on our x side. Okay. Now let's take a look at part B. How far from the base of the cliff does the stone hit the ground? This refers to how far from the base of the cliff. That is, take a look at the hint in the parentheses. This is just looking at the x-axis. So here we're looking for a distance in the x direction. So we're looking for dx. And looking at our equations here, v is equal to d over t is the only equation we can ever use in the x direction. So v is equal to d over t. Our v here in the x direction is 5 meters per second. That is equal to d over 4 seconds is our time. Therefore, our distance, 5 times 4, is 20 meters. Okay. Now part C. What are the horizontal and vertical components of the stone's velocity just before it hits the ground? Now we're looking for both the horizontal and vertical components of the velocity. That's the final velocity there. Okay. Start off with, what is the x component, the horizontal component? Well, because according to theory, it stays constant. If it started out with 5, it should also end with 5. So our v final in the x direction is 5 meters per second. Now how about the y direction? How do we find that in the y direction? So let's see. Looking here for VF in the y. And looking at our pieces of information, we can use either this equation or this one. I probably would prefer this one, just because it's shorter and we don't have to deal with the squares in this one. Okay. Either way, you'll get the same answer. Oops. Wow, I write the wrong equation. Okay, VF is what we're solving for. Oops. This crosses off to 0. So we're just left with 9.8 meters per second squared times time, 4 seconds. Therefore, our VFY is equal to, that should be about, the answer should be about 39.2 seconds. No, meters per second, my mistake. So 39.2 meters per second. Okay. Now the last part. What is the resultant velocity of the stone when it hits the ground? So now we have both an x and a y component. We combine these two together using the Pythagorean theorem. Okay, so let's put that on the side here. Okay, so 5 squared plus 39.2 squared is equal to c squared. When you solve for c, which is the same as our final velocity, you should get 39.5 meters per second. And that is our final answer. There you go. How was that? Okay, now let's move on to example 2, and we're going to work on this blank space here. So, Lucy and her friend are working at an assembly plant making wooden toy giraffes. At the end of the line, the giraffes go horizontally off the edge of the conveyor belt and fall into a box below. If the box is 0.6 meters below the level of the conveyor belt and 0.4 meters away from it, what must be the horizontal velocity of the giraffes as they leave the conveyor belt? Okay, and the hint in parentheses says first find the time and then find out the horizontal velocity. Okay, so let's first start out with a picture here. So let's say this is the conveyor belt. And this is going to represent our toy giraffe. I'm not drawing an actual giraffe. And then it's going to land in this box. Well, that giraffe looks bigger than the box. Well, let's leave it at that. Okay. So if the box is 0.6 meters below it, this distance here is 0.6 meters. Whereas this distance is 0.4 meters. That should be a 4. Let me rewrite that. Okay. Then off to the side, we're going to split off our variables into x and y. Okay. So this 0.6 meters, this is a height, therefore it's a vertical distance. So we're going to write that there as our dy. And then this 0.4 meters is our dx. Okay. Then we go off to list our assumptions. Okay. Anything else? So, the hint says to first find the time. So we need to find what time is to link both dimensions here. And looking back at our equations, the only equation that fits the bill to find time is this one. D is equal to VIT plus 1/2 AT squared. So that's 1/2. Okay. Plug it in. We get 0.6 meters is equal to VIT, so VI is 0, so that crosses off. 1/2 9.8 meters per second squared times t squared. Solving for time, you guys should get 0.35 seconds. Okay, so after we find the time, now we could find the horizontal velocity, Vx. And looking at our equations, the only equation that fits the bill is V is equal to d over t. Our velocity, that is what we're solving for. Our distance is 0.4 meters. Our time is 0.35, so 0.4 divided by 0.35 should get you 1.14 meters per second. So Vx is equal to 1.14 meters per second, and let's box that off to indicate that's our final answer. And there we go. Now for our final example, turn to page 5 for example 3. You are visiting a friend from elementary school who now lives in a small town. One local amusement is the ice cream parlor where Stan, the short order cook, slides his completed ice cream sundaes down the counter at a constant speed of 2.0 meters per second to the servers. If the servers catch the sundaes 7.0 centimeters from the edge of the counter, how far do they fall from the edge of the counter to the point at which the servers catch them? Okay, So let's draw ourselves a counter where we have these awesome sundaes. Sliding down the counter at a speed of 2.0 meters per second. Then they fall off. Well, let's draw the projected path. Okay, so then let's say this distance here from the edge of the counter, according to the prompt, is 7.0 centimeters. Okay, and the question is asking how far do they fall from the edge? How far down? So we're looking for this sort of distance here. And then let's list off to the side our variables, x and y. So this 2.0 meters per second is in the horizontal direction, and therefore that is our x velocity. We're also, oops, whoa, let's erase that. Okay. We're also given here a distance in the x direction, 7.0 centimeters. As a note for our calculations, we got to put it in meters. So that is 0.07 meters. And in our y direction, they didn't give us any pieces of information, so we only have our assumptions. Meters per second squared. VIY is 0 meters per second. And before we can get anywhere, we need to find time. Let's set it up here as time. So the only way we could find time is in the x direction this time. So the equation we can only use is v is equal to d over t. Here, v is 2.0 meters per second, equal to our distance of 0.07 meters over time t. Solving for t, you guys should get 0.035 seconds. Okay, so now we can write that over here. 0.035 seconds. 0.035 seconds. Okay, now that we have a time, let's look back at our y dimension and see if we could solve for that distance in the y. So can we? Do we have enough information? Yes, we do. Now we gotta use this equation right here. D is equal to VIT plus, let me rewrite that, VIT plus 1/2 AT squared, or D. Okay, now we're solving for D in the y direction. D is equal to VIT, as VI is 0, so that crosses off. 1/2 9.8 meters per second squared, and t squared, t is 0.035 seconds. Don't forget to square that. Plug that in. Solving for d in the y direction should get you 0.006 meters, and when you convert that to centimeters, that's 0.6 centimeters. So in comparison to our 7 centimeters, this is very small. Let's box that off to show that's our final answer. And there is the end of example 3. Now how was those problems? Stay tuned for more problem solving examples, guys.